Imagine staring into the universe's infancy, where galaxies were just forming fuzzy, red-hued specks barely clinging to existence. The James Webb Space Telescope captured these little red dots as they once were, ancient, faint, and fragile. But now, something strange is happening. These primordial galaxies, once glowing faintly in the cosmic dark, are vanishing. Not fading gradually, but disappearing entirely, like stars blinking out of existence. Scientists are stunned. These objects, remnants of the universe's earliest days, should be enduring. Yet JWST's data shows they're vanishing faster than expected, leaving behind a void in the cosmic timeline. Why? Could their light be dimming due to some unseen force? Or are they evolving into something we can't yet detect? The mystery deepens. If these cosmic dinosaurs are fading, what does that mean for the universe's future? And if they vanish completely, will we ever glimpse their final moments? In the vast, ancient cosmos, a strange and subtle disappearance has been unfolding, quiet, almost imperceptible, yet deeply significant. The James Webb Space Telescope, our most powerful cosmic eye, has revealed something unexpected. The so-called little red dots, young, massive stars in the early universe, are fading from view. This isn't just a technical glitch or an observational error, it's a potential cosmic puzzle that could reshape our understanding of how the universe formed and evolved. Just as dinosaurs didn't vanish but instead evolved into birds, these stars may not be disappearing at all, but transforming in ways we've yet to comprehend. What we're witnessing is not an end, but a transition, a hint that the universe is far more dynamic and mysterious than we thought. To grasp this discovery, we need to step back and look at what the little red dots actually are. These are not ordinary stars, they are the first generation of stars to form in the universe, born in the dense, primordial clouds of gas that existed just a few 100 million years after the Big Bang. These stars, often referred to as population 3 stars, were massive, many tens of times the mass of our Sun, and extremely luminous. They were the cosmic forerunners of the stars we see today, the building blocks of galaxies and the seeds of heavier elements that eventually gave rise to planets and life. But these stars didn't last long. Due to their immense mass, they burned through their fuel rapidly, living only a few million years before exploding as supernovae. Yet, the James Webb Space Telescope has detected these stars in their earliest stages, glowing faintly in the distant universe, and now, something is changing. The key to understanding this phenomenon lies in the way light travels across the universe. Light from these distant stars takes billions of years to reach us, meaning we're seeing them as they were in the past. The James Webb Space Telescope, with its advanced infrared capabilities, can peer deeper into the cosmos than ever before, capturing light that has journeyed for over 13 billion years. This allows us to study the earliest galaxies and the stars within them. However, recent observations have revealed a peculiar pattern. These young stars, once bright and distinct, are now dimming. Some have vanished entirely from the telescope's view, while others are appearing fainter than expected. This isn't a sudden disappearance, but a gradual fading, as if the stars themselves are undergoing a transformation. At first, scientists considered a few possible explanations. One theory suggested that the stars might be evolving. Since these stars are so massive, they burn through their fuel quickly, and their life cycles are compressed compared to stars like our Sun. If they are indeed evolving, their brightness could naturally decrease as they age. However, this explanation doesn't fully account for the observed changes. For instance, the rate at which these stars are fading seems inconsistent with simple stellar evolution models. Another possibility is that the stars are being obscured by intervening material. Dust and gas in the early universe could block or scatter some of their light, making them appear dimmer. But again, this doesn't explain the widespread and systematic nature of the fading. What if the problem isn't with the stars themselves, but with our understanding of the universe's early history? The James Webb Space Telescope's observations have already challenged many long-held assumptions about the early universe. For example, it revealed that the first galaxies formed earlier than previously thought, and that they were more complex and structured than expected. Now, the fading of these stars could be another sign that our models are incomplete. If these stars are disappearing from view, it might mean that our current theories about star formation, galaxy evolution, and the distribution of dark matter are missing crucial pieces of the puzzle. To explore this further, scientists are turning to a combination of observational data and theoretical models. The James Webb Space Telescope's instruments are being used to study the light from these stars in greater detail, looking for clues about their composition, temperature, and energy output. By analyzing the light spectra, researchers can determine the chemical makeup of these stars and how they interact with their surroundings. For example, if the stars are losing mass through stellar winds or if they are interacting with nearby gas clouds, this could affect their brightness. Additionally, the telescope's ability to detect faint, distant objects means that even if these stars are dimming, they might still be observable in the infrared spectrum, where the James Webb excels. Another angle of investigation involves comparing the observed data with simulations of the early universe. Scientists are running computer models to recreate the conditions of the cosmos shortly after the Big Bang, testing how stars would form, evolve, and interact with their environments. These simulations help predict what the James Webb Space Telescope should see, allowing researchers to compare theoretical expectations with actual observations. If the models don't align with the data, it could indicate that something fundamental about the universe's behavior is still unknown. For instance, if the stars are fading because they are being consumed by dark matter or if their light is being distorted by gravitational lensing, these effects would need to be accounted for in the models. The implications of this discovery extend beyond the study of individual stars. If these early stars are indeed fading or disappearing, it could have profound consequences for our understanding of the universe's life cycle. Stars like these were crucial in shaping the cosmos, as they produced the heavier elements necessary for planets and life. Their rapid demise through supernovae seeded the universe with these elements, allowing subsequent generations of stars to form. If their life cycles are shorter or more variable than previously thought, it could affect our models of how elements are distributed across the universe and how galaxies evolve over time. Moreover, the fading of these stars might indicate that the early universe was more chaotic or dynamic than we anticipated, with processes occurring on timescales that challenge our current understanding. One of the most intriguing aspects of this puzzle is the possibility that the stars are not actually disappearing but are undergoing a transformation that we have yet to fully comprehend. Just as the dinosaurs evolved into birds, these stars might be evolving in ways that are not yet recognized. For example, they could be transitioning into different types of stars, such as lower-mass stars or brown dwarfs, which would explain their dimming. Alternatively, they might be part of a larger, more complex system of stars and gas that we haven't yet observed. The James Webb Space Telescope's ability to peer into the early universe means that we are now able to study these stars in unprecedented detail, but the data we're seeing is raising more questions than answers. As scientists continue to analyze the data, they are also considering the possibility that the fading stars could be a sign of something even more fundamental. The early universe was a time of intense activity, with galaxies forming, stars bursting into existence, and matter clumping together in ways that are still being unraveled. If these stars are fading, it could be an indicator that the universe is still actively changing, even billions of years after the Big Bang. This challenges the notion that the universe is a static, predictable system and suggests that there may be processes at play that we have yet to discover. For example, if the stars are interacting with dark energy or if their light is being affected by the expansion of the universe itself, these factors could be contributing to their apparent dimming. In the end, the disappearance of the little red dots is not just a mystery about stars, it's a window into the deeper, more complex nature of the cosmos. The James Webb Space Telescope has already revolutionized our understanding of the universe by revealing its early history in stunning detail. Now, as these stars fade from view, it's a reminder that the universe is still full of surprises. The fact that these stars are disappearing could mean that we're on the brink of discovering new physics, new processes, or even new ways of thinking about the fundamental forces that shape the cosmos. Whether they are evolving, being obscured, or undergoing some other transformation, their fading is a call to continue exploring, to question our assumptions, and to embrace the unknown. After all, the universe has always been a place of mystery, and the James Webb Space Telescope is helping us uncover its secrets, one fading star at a time. The James Webb Space Telescope, with its unparalleled ability to peer into the cosmos, has revealed a phenomenon that has captivated astronomers and sparked new questions about the universe's origins. Among its earliest images, a peculiar sight emerged: faint, red, glowing objects that seemed to flicker in and out of existence. These were later dubbed the little red dots, a term that has since become synonymous with a cosmic mystery. But how did scientists first detect these enigmatic points of light,
and what methods allowed them to track their disappearance over time.
The journey to uncover their fate is a testament to the power of modern astronomy and the relentless pursuit of knowledge. The story begins with the James Webb Space Telescope itself, a marvel of engineering designed to observe the universe in the infrared spectrum. Unlike its predecessor, the Hubble Space Telescope, which primarily captured visible light, JWST's instruments are optimized to detect the faint, redshifted light from distant celestial objects. This capability was crucial in identifying the little red dots, which are so distant that their light has been stretched into the infrared wavelengths. The telescope's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, played pivotal roles in capturing these objects, their faint glow barely perceptible against the backdrop of space. The initial discovery of the little red dots occurred during JWST's first batch of images, released in July 2022. These images, taken just months after the telescope's launch, showcased a vast expanse of the universe, revealing thousands of galaxies and other celestial phenomena. Among them were these mysterious red dots, which appeared to be faint, glowing points of light. At first, scientists speculated that they might be distant galaxies, their light stretched into the red part of the spectrum due to the expansion of the universe. However, further analysis would challenge this assumption. To understand the nature of these objects, astronomers turned to a combination of observational techniques and data analysis. One of the key methods involved repeated observations over time. By capturing multiple images of the same region of space at different intervals, scientists could monitor how these dots changed. This approach allowed them to track their brightness and position, revealing that some of the little red dots were indeed fading. The process was meticulous, requiring precise calibration of JWST's instruments and careful comparison of datasets to account for any instrumental effects or cosmic variations. Another critical factor in confirming the disappearance of the little red dots was the use of long-exposure imaging. JWST's sensors are designed to accumulate light over extended periods, which is essential for capturing faint objects. However, this also means that any changes in the brightness of an object over time can be detected. By analyzing the light curves, graphs that plot the brightness of an object over time, scientists could observe the gradual dimming of some of these dots. This dimming suggested that the objects were not static, but rather undergoing some form of evolution or transformation. The collaboration between different scientific teams was instrumental in piecing together the puzzle. Astronomers from around the world contributed their expertise, analyzing data from various instruments and cross-referencing findings with existing knowledge. For example, some researchers focused on the spectral characteristics of the little red dots, using JWST's spectroscopic capabilities to determine their composition. Others examined the surrounding environment, looking for signs of interactions with other celestial bodies or the influence of cosmic phenomena like gravitational lensing. One of the most intriguing aspects of the little red dots is their potential connection to the earliest stars in the universe. These stars, which formed just a few 100 million years after the Big Bang, were massive and short-lived, often ending their lives in spectacular supernova explosions. If the little red dots were the remnants of such stars, their fading could be explained by the natural life cycle of these celestial bodies. However, this hypothesis remains under investigation, as scientists continue to gather more data to confirm or refute it. The timeline of the discovery and analysis of the little red dots is a story of patience and perseverance. The initial images captured in 2022 provided the first glimpse, but it took months of careful observation and data processing to begin understanding their behavior. By 2023, scientists had already noted the gradual dimming of some of these objects, prompting further questions about their nature. The process of confirming their disappearance required not only advanced technology but also a deep understanding of the universe's dynamics, as well as the ability to interpret complex datasets. The significance of this discovery extends beyond the little red dots themselves. Their fading represents a broader cosmic puzzle, one that challenges existing theories about the formation and evolution of the universe. If these objects are indeed the remnants of the first stars, their disappearance could provide crucial insights into the early stages of star formation and the role these stars played in shaping the cosmos. Moreover, the methods used to study the little red dots, such as long-exposure imaging and spectral analysis, highlight the power of modern telescopes in uncovering the universe's hidden secrets. As scientists continue to analyze data from JWST,
the story of the little red dots is far from complete.
New observations and technological advancements may yet reveal more about these enigmatic objects, potentially leading to breakthroughs in our understanding of the universe's origins. The journey to uncover their fate is a reminder of the complexities of cosmic phenomena and the enduring curiosity that drives scientific exploration. In the end, the disappearance of the little red dots is not just a mystery to be solved, but a gateway to deeper questions about the nature of existence itself. Just as the dinosaurs didn't disappear but rather evolved into birds, cosmic dinosaurs in the form of the JWST's little red dots may fade away completely. This part of our deep dive into the James Webb Space Telescope's disappearing little red dots may lead to another cosmic puzzle focuses on, go deeper into the underlying science/physics/astronomy that makes this significant. Explain why it matters to our understanding of the universe, in accessible plain language. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For viewers who want to go deeper than this summary, the primary source linked in the description lays out the full technical picture. Findings like this rarely stand alone, they get compared against earlier observations to make sure the pattern holds up under scrutiny. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For decades, astronomers have gazed at the cosmos, piecing together the story of how stars and galaxies formed. The early universe, a time of chaos and creation, has long been a mystery. In the 1960s and 1970s, scientists began to theorize that the first stars, massive, luminous objects, emerged from the primordial darkness. These stars, they believed, would be the seeds of all future cosmic structures, their light illuminating the void. But how? How could such ancient stars be detected, and what would they look like? The answers lay hidden in the depths of space, waiting to be uncovered by the tools of observation. Early telescopes, limited by their technology, could only capture glimpses of the distant universe. It wasn't until the 1990s that the Hubble Space Telescope revolutionized our view. Launched in 1990, Hubble's sharp vision allowed astronomers to peer deeper into space than ever before. Its images revealed distant galaxies, nebulae, and the faint glow of young stars. Yet, even with Hubble's capabilities, there were limits. The universe was expanding, and the light from the earliest stars had been stretched over billions of years, making them appear faint and elusive. Scientists needed a new tool, one that could see beyond the visible spectrum, where the light of these ancient stars might still linger. Enter the Spitzer Space Telescope, launched in 2003. Operating in the infrared range, Spitzer could detect the faint, reddish glow of objects obscured by cosmic dust. This was a breakthrough. Infrared light, which is invisible to the human eye, carries the signatures of heat and energy from distant sources. Spitzer's observations began to paint a clearer picture of star-forming regions, revealing the presence of young stars shrouded in gas and dust. But even Spitzer had its constraints. Its mirror was smaller than what was needed to capture the faintest signals from the earliest stars. The quest for deeper understanding demanded a leap in technology. The James Webb Space Telescope, launched in 2021, was designed to fill this gap. With its massive mirror and advanced infrared instruments, JWST could peer further back in time than any previous telescope. Its primary mirror, 2.4 times larger than Hubble's, collects more light, allowing it to detect fainter objects. The telescope's instruments are tuned to the infrared spectrum, where the light from the earliest stars and galaxies has been stretched over cosmic distances. When JWST first began its observations, it revealed something astonishing:
a population of tiny, red dots in the distant universe.
These objects, dubbed the little red dots, were initially thought to be the first stars, massive, short-lived entities that would eventually collapse into black holes or explode as supernovae.
Their red color, a signature of their extreme heat, hinted at their youth and intensity. But as JWST's observations continued, a puzzling phenomenon emerged.
These little red dots, once thought to be the precursors of the universe's first stars, began to fade. Some appeared to vanish entirely, their light dimming or disappearing altogether.
This was a revelation. It suggested that our understanding of these ancient objects was incomplete. The question arose, were these dots truly the first stars, or something else entirely?
The disappearance of these objects challenged existing models of star formation. For decades, scientists had assumed that the earliest stars would be massive, luminous, and short-lived.
Their light would dominate the early universe, leaving behind remnants like black holes or neutron stars. But JWST's data suggested a different story. The little red dots, if they were indeed the first stars, were not behaving as expected. Instead of fading into oblivion, they seemed to be evolving or perhaps disappearing altogether. This raised a fundamental question: what if our understanding of the earliest stars was wrong? The history of astronomy is one of continuous refinement. Earlier theories about star formation were built on limited data, and each new telescope brought fresh insights. The Hubble Space Telescope, for example, revealed the existence of distant galaxies and helped map the distribution of dark matter. Spitzer's infrared capabilities allowed scientists to study the birth of stars within dusty nurseries, uncovering the role of molecular clouds in stellar formation. Yet, even with these advances, the earliest stars remained a mystery. The James Webb Space Telescope, with its unprecedented sensitivity, was designed to solve this puzzle. Its ability to detect faint infrared light meant it could observe objects that had previously been invisible. The little red dots, however, presented a new challenge. Their disappearance suggested that the processes governing their evolution were more complex than previously thought. Perhaps these objects were not the first stars at all, but something else entirely. Maybe they were intermediate stages in the formation of stars, or perhaps they were entirely different types of celestial bodies. The analogy to dinosaurs is apt here. Just as dinosaurs didn't vanish but evolved into birds, these cosmic dinosaurs might not have disappeared but transformed in ways we haven't yet understood. The disappearance of the little red dots could be a sign of a new evolutionary path in the cosmos. This idea challenges the long-held assumption that the first stars were massive and short-lived. Instead, it suggests that the early universe might have been more dynamic, with a variety of stellar objects contributing to its development. The implications are profound. If the little red dots are not the first stars, what are they? Are they remnants of earlier stellar generations, or entirely new types of objects? These questions are driving new research and theoretical models. Scientists are now re-examining the data from JWST, looking for patterns and clues that might explain the disappearance of these objects. Some theories propose that the little red dots could be protostars, objects in the early stages of star formation that are still gathering mass and will eventually ignite as full stars. Others suggest they might be brown dwarfs, failed stars that never reached the critical mass to sustain fusion. Still, other hypotheses point to entirely new phenomena, such as exotic forms of matter or interactions between dark matter and ordinary matter. The mystery of the little red dots is not just about their disappearance, it's about the broader story of how the universe evolved. It's a reminder that our understanding of the cosmos is always evolving, shaped by new observations and technologies. The James Webb Space Telescope has opened a new window into the universe, revealing details that were once hidden. Its findings are not just about the past, they are about the present and the future of our cosmic understanding. As scientists continue to analyze the data, they are uncovering new layers of complexity in the story of star formation. The little red dots, once thought to be the first stars, may instead be part of a larger, more intricate narrative. This is the power of observation. It challenges our assumptions and forces us to rethink what we know. The disappearance of these dots is not an end, but a beginning. It is a call to explore deeper, to ask more questions, and to embrace the unknown. In the vast expanse of the universe, every observation is a step closer to understanding our place in it.
The journey of discovery continues, driven by curiosity and the relentless pursuit of knowledge. The James Webb Space Telescope has been rewriting the story of the early universe, revealing cosmic phenomena that challenge our understanding of how stars and galaxies formed. Among its most intriguing discoveries are the so-called little red dots, tiny, faint glows in the distant past that once seemed to represent the first stars to ever shine. But now, as astronomers peer deeper into the data, these dots are fading from view, raising a question that feels almost poetic. What if these cosmic dinosaurs, as some have called them, are not disappearing but evolving into something else entirely? The mystery of their vanishing is not just a technical puzzle, it's a gateway to rethinking the very foundations of star formation and the universe's early history. Yet, for all the excitement, the answers remain elusive, and the debate over what these dots truly are and what their disappearance signifies has only just begun. When the James Webb Space Telescope first captured images of the early universe, it revealed a sky teeming with faint, glowing objects. Among them were these little red dots, which scientists initially interpreted as the first stars to ever form. These stars, they believed, were massive, short-lived, and incredibly bright, so bright that their light could be detected billions of years after they formed. But as more data came in, something strange happened. The dots, which had once been clearly visible, began to fade. Some appeared to vanish entirely, while others dimmed to the point of becoming indistinguishable from background noise. This wasn't just a technical glitch or an error in the telescope's calibration, it was a fundamental shift in what the data was revealing. The dots were no longer where they were expected to be, and their absence was as puzzling as their presence had been. The initial interpretation of these dots as the first stars was based on their appearance and their location in the early universe. These objects were found in regions of space where the universe was only a few 100 million years old, a time when the cosmos was still young and dense. At that point, the universe had only just begun to form its first galaxies, and the conditions for star formation were thought to be extreme. Theorists had long predicted that the first stars, or population 3 stars, would be massive, with masses hundreds of times that of our Sun. These stars would burn brightly, then collapse under their own gravity, and explode as supernovae, seeding the universe with heavier elements. But the little red dots didn't quite fit this picture. They were too faint, too small, and their light didn't match the expected signatures of massive, short-lived stars. Instead, they seemed to glow with a more moderate brightness, suggesting a different kind of star, or perhaps something entirely different. This discrepancy has led to a growing divide among astronomers. On one side are those who believe the dots are indeed the first stars, but their apparent fading is due to a combination of factors. For example, these stars might have been surrounded by thick clouds of gas and dust, which could have obscured their light from our view. Alternatively, they might have been part of a larger structure, such as a star cluster or a protogalaxy, where their light was diluted by the presence of other stars. Another possibility is that the dots are not individual stars at all, but rather the collective glow of many small stars, each too faint to be detected on its own. If that's the case, their apparent disappearance could be due to the telescope's sensitivity limits, or perhaps the way light travels across the vast distances of space. However, these explanations are not without their challenges. For instance, if the dots were part of a larger structure, why do they seem to fade in some regions but not others? And if they are not individual stars, why do they appear as distinct points of light rather than a diffuse glow? On the other side of the debate are those who argue that the little red dots may not be stars at all. This hypothesis is rooted in the idea that the early universe might have produced a different kind of object, one that doesn't fit the traditional model of star formation. One possibility is that these dots are not stars but instead brown dwarfs, which are substellar objects that never quite reach the mass needed to sustain nuclear fusion. Brown dwarfs are often referred to as failed stars, and they emit light in the infrared spectrum, which is precisely the wavelength range that the James Webb Space Telescope is optimized to observe. However, brown dwarfs are typically much cooler and dimmer than the stars we see in our own galaxy, so their presence in the early universe would have been a surprising discovery. Another theory suggests that the dots could be the remnants of the first galaxies, which might have formed in a way that left behind faint, glowing structures. These structures could have been the result of mergers between smaller protogalaxies, or they could have been the result of a different kind of star formation process altogether. If these dots are not stars, but something else entirely, their disappearance could indicate that they are simply not detectable with current technology or that they are part of a larger, more complex system that we have yet to understand. The implications of these debates are far-reaching. If the little red dots are indeed the first stars, their fading could mean that our understanding of star formation in the early universe is incomplete. For example, if these stars were smaller and longer lived than previously thought, they could have played a different role in the formation of the first galaxies. They might have contributed more to the formation of heavier elements, or they might have influenced the distribution of dark matter in ways we haven't yet considered. On the other hand, if the dots are not stars at all, their disappearance could challenge the very foundation of our models for how the universe evolved. It could mean that the first stars were not the dominant force in shaping the cosmos, or that the processes of star formation and galaxy formation are more complex than we have assumed. Either way, the mystery of the little red dots forces us to reconsider the assumptions that have guided our understanding of the early universe. What makes this puzzle even more intriguing is the fact that the James Webb Space Telescope is still in the early stages of its mission. The data it has collected so far is vast, but it's not yet complete, and new observations are continually being made. This means that the story of the little red dots is still being written, and the answers we seek may not be found in the data we have today. Instead, they may lie in the next generation of telescopes, which will have even greater sensitivity and resolution. For example, future missions like the Nancy Grace Roman Space Telescope or the James Webb successor could provide deeper insights into the nature of these dots by observing them in different wavelengths or by capturing more detailed images of their surroundings. These observations could help determine whether the dots are stars, brown dwarfs, or something entirely new. They could also shed light on the conditions of the early universe, revealing whether the processes that led to star formation were uniform across the cosmos or if there were variations that we have yet to detect. At the heart of this mystery is a fundamental question: what does it mean to be a star? For centuries, astronomers have defined stars as massive, luminous objects that sustain nuclear fusion in their cores. But the discovery of the little red dots challenges this definition, suggesting that there may be other ways for light to be produced in the early universe. If these dots are not stars, they could represent a new class of objects that defy our current understanding. This possibility is both exciting and unsettling, as it forces us to confront the limits of our knowledge. It also raises the question of whether our models for star formation are too rigid, or if they need to be reimagined to account for the diversity of objects that may have existed in the early universe. In this sense, the fading of the little red dots is not just a technical anomaly, it's a call to re-examine the very foundations of astrophysics. The search for answers to this mystery is not just a scientific endeavor, it's a testament to the human spirit of curiosity and the relentless pursuit of knowledge. Every time we look at the cosmos, we are reminded that there is still so much we don't know. The little red dots, with their enigmatic disappearance, are a reminder that the universe is full of surprises, and that our understanding of it is always evolving. As astronomers continue to analyze the data from the James Webb Space Telescope, they are not just uncovering the secrets of the early universe, they are also challenging the assumptions that have shaped our view of the cosmos for decades. Whether the dots are stars, brown dwarfs, or something entirely new, their story is a powerful illustration of how science works, by asking questions, testing hypotheses, and embracing the unknown. In the end, the mystery of the little red dots may not have a single answer, but it will undoubtedly lead to new discoveries that reshape our understanding of the universe and our place within it. Just as the dinosaurs didn't disappear but rather evolved into birds, cosmic dinosaurs in the form of the JWST's little red dots may fade away completely. This part of our deep dive into the James Webb Space Telescope's disappearing little red dots may lead to another cosmic puzzle focuses on, explain what's coming next, future missions, instruments, or observations that could confirm, extend, or challenge what we know so far. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. For viewers who want to go deeper than this summary, the primary source linked in the description lays out the full technical picture. Findings like this rarely stand alone, they get compared against earlier observations to make sure the pattern holds up under scrutiny. Scientists are still cross-checking the data before drawing firm conclusions, which is exactly the kind of patience that makes space science trustworthy. None of this comes from speculation, it comes from instruments built to measure faint signals that the naked eye could never pick up on its own. It's easy to forget how much coordination sits behind a single headline like this: years of engineering, calibration, and review before anyone announces anything. That's part of why stories like this take time to fully confirm. Good science moves carefully, even when the early results already look remarkable. As we close this deep dive, 3 ideas linger like the fading glow of those little red dots. First, the galaxies once dubbed the little red dots, those ancient, faint smudges captured by the James Webb Space Telescope, are vanishing from view. Not fading into oblivion, but disappearing in ways that defy simple explanations. Their light, once detectable, is now slipping away, leaving astronomers scrambling to decode why. Second, this mystery mirrors a deeper pattern in the universe: transformation. Just as dinosaurs didn't vanish but evolved into birds, these galaxies may be undergoing a metamorphosis. Perhaps they're shifting into new forms, their star-forming activity dimming as they mature, or their light is being obscured by unseen cosmic forces. Third, this puzzle isn't just about distant galaxies, it's a reminder that the universe is still full of surprises. The JWST's ability to peer back billions of years has already upended our understanding of star formation, dark matter, and the early cosmos. Now, its data is revealing a new layer of complexity, that even the most ancient celestial objects might not be static relics, but dynamic entities in a constant state of change. So what's causing these dots to fade? Is it a trick of the telescope's instruments, a hidden layer of dust in the cosmos, or something even more radical, a fundamental shift in how we perceive the life cycles of galaxies? The answers could rewrite the story of how the universe evolved. But for now, the mystery remains, a quiet echo from the edges of time. If you followed this journey, you've seen how science thrives on questions as much as answers. The universe doesn't just give us facts, it challenges us to imagine, to question, and to dig deeper. So if you're curious about what comes next, hit that subscribe button to join FactVerse for daily deep dives into the cosmos. And if you've got your own theory about the little red dots or any cosmic puzzle that's been puzzling you, drop a comment below. After all, the greatest discoveries often begin with a single question. Until next time, keep looking up.